What are the soil strengths for soils with different moisture levels?
So, to give some background information, soil is the loose surface material that covers most land and it provides structural support to stabilize buildings. Therefore, the right type of soil is important to make a strong foundation. Soil strength has two parts, shear and tensile strength, and with a higher soil strength, buildings will be able to withstand more natural disasters and erosion. Of course, there have been past attempts of people conducting similar experiments as stated above. Firstly, our research hypothesis is that soils with a higher moisture level will have greater shear and tensile strength. Our independent variable is the moisture level of soil, while our dependent variable is shear and tensile strength. We have three control variables, namely the mass of soil, the same equipment, and the same location of the experiment.
Before the experiment, first place newspaper on the table. Second, get ready to alkalize. Third, cut the soils equally. Fourth, pour different masses of alkalize. Fifth, ensure the masses of soils are similar. Lastly, measure the moisture levels. For shear, first insert the device into the soil and turn the reading to 0. Rotate the device clockwise until the soil matrix fills, then multiply the reading by the vein size. For tensile, place one portion between two steel discs. Apply vertical load slowly until the soil reaches failure. Then use the formula to calculate tensile strength. Repeat the experiments for both shear and tensile. If our two hypotheses are true, our graphs will show our trend lines going upwards, showing that both shear and tensile strength increase as the moisture level increased.
Here are our results. The table shows the shear and tensile strength readings against the moisture levels respectively. For visualization purposes, we will transfer our data into a line graph as shown here. Here are the highest and lowest values that we got for shear and tensile strength respectively. As we can see, the shear strength decreases as the moisture level increases. Therefore, we can conclude that hypothesis 1 is false. As for tensile strength, our results show that the tensile strength increases as the moisture level increases. Therefore, we can conclude that our hypothesis 2 is true. So here are some limitations that we face, mostly due to human error, and some recommendations for the future, such as having better planning.
Our purpose, research, and question are happily stated again. Our graphs show the range of moisture levels and the lowest and highest values. As the moisture level increased, shear strength decreased and tensile strength increased. We contributed by making a correlation between the shear and tensile strength of soils and their moisture levels, helping choose suitable soils for the moat structures. With our research results, construction companies can use better soils, allowing buildings to be safer and stronger and reducing additional costs. Further investigation and research should observe the relationship between other soils' moisture levels and their strengths, like studying the effect of moisture level on a granular soil. For global issues, we are trying to reduce unstable buildings so they can withstand natural disasters and the test of time. Nations can then identify good construction soils for better infrastructure. For personal effectiveness, we honed our research skills, became better at organizing and analyzing our data, and became more cautious during our experiments. For interpersonal effectiveness, our collaboration helped us understand and implement each other's viewpoints and resolve arguments faster.